Hi, my name is Talia Davis. I am a senior at the Neighborhood Academy, and I am in the Science Year seminar. What brought my interest in this topic is that I am big on taking care of your teeth. In this Science Year seminar project, I will be studying potassium nitrate in sensitive teeth toothpaste using atomic emission spectroscopy technique, typically referred to as an atomic absorption spectrometer, to determine if labels are accurate. Presentation outline. Toothpaste basics, role of potassium nitrate, experimental results, discussion, conclusion. Most of you probably know that fluoride is an active ingredient of most toothpaste. This is because fluoride prevents cavities by strengthening the enamel on your teeth. Toothpaste manufacturers have choices of which fluoride-containing ingredient to use. Here I list three of the most common compounds: sodium fluoride, stannous fluoride, and sodium monofluorophosphate. Toothpaste also contains abrasives that help remove food debris. There are also seltzers or detergents which help the toothpaste foam as you brush. Of course, we want to encourage brushing, so flavoring agents and sweeteners are added for taste. Some specialized toothpaste, such as Sensodyne, adds a desensitizer to treat sensitive teeth. This is because more than 12% of patients had sensitive teeth in the Northwest U.S., according to the American Dental Association. Scientists have primarily accepted Brandstrom's hydrodynamic theory to explain why teeth may be sensitive. Let me now tell you about the hydrodynamic theory. First, let's look at the anatomy of a tooth. Here's a cutaway diagram that shows the different layers: enamel, dental, pulp, as well as the gum surrounding the tooth. Notice the pulp has nerves. If we zoom in on a smaller section of the tooth, we can see that there are actually tubules within the dentin that connect between the surface of the tooth and the nerves in the pulp. The tubules in the tooth have fluid in them. The hydrodynamic theory states that changes in fluid pressure within the tubules affects the nerves, which causes sensitivity. There are several common stimuli that causes a pain response, but the most common is temperature. Eating foods and drinks that are very hot or cold can expand or contract the fluid, which causes a pressure change. Potassium nitrate. The most cost-effective method of treating sensitive teeth is using a sensitive toothpaste. There are several chemicals that have been identified as desensitizers, but the most commonly used agent is potassium nitrate. The potassium ion is what's doing the job. Nitrate is just a counter ion that is soluble and non-toxic. Two mechanisms of action: blocking the synapse between the nerve cells, swapping out the nerve to prevent signaling. Arbolating tubules minimizes diameter of tubule, which restricts any flow or fluid change in pressure. Orchardson and Gillian reviewed 16 clinical trials of potassium-containing toothpaste, which were all double-blind and randomized studies. In these studies, there were three different methods used, such as tactile stimuli, cold air stimulus, and patient subjective ratings on surveys. All of the 6 studies using this threshold force as the measure showed a significant difference between experimental and control. 8 of 11 studies that assessed sensitivity using a cold stimulus showed a statistically significant difference between experimental and control groups with respect to percentage reduction in sensitivity. In the vast majority of self-reporting studies, they reported that patients experienced a relief of sensitivity. As I mentioned at the beginning of my presentation, the title of my project is Atomic Emission Spectroscopy Comparison of Potassium Nitrate Concentration in Sensitive Teeth Toothpaste, or labels accurate. I am interested in seeing if it is worthwhile to pay for Sensodyne if I can get the same benefits from a less expensive alternative. Therefore, I measured the concentration of potassium nitrate in 3 different toothpastes marketed for the treatment of sensitive teeth that contain potassium nitrate. I used atomic emission spectroscopy to detect potassium at Robert Morris University. My research question is, does the concentration of potassium nitrate measured in the lab match the concentration listed on the ingredient label of each toothpaste? Which brand provides the most cost-effective potassium nitrate treatment? Toothpaste brand comparison. These are the 3 brands of toothpaste: Colgate, Top Care, and Sensodyne. I tested using the atomic emission spectroscopy technique. This table also includes their active ingredients and price per ounce. 6 standards of potassium nitrate were prepared in a range of 0 to 20 parts per million by diluting 1,000 parts per million potassium standard in a solvent composed of 3 to 4% nitric acid and containing 1,000 parts per million of cesium chloride. Preparation of toothpaste samples. A 1 milliliter aliquot of each toothpaste will dissolve in 100 milliliters of 3 to 4% nitric acid containing 1,000 parts per million of cesium chloride. This solution was subsequently diluted by a factor of 10 using the same solvent. Hence, the 1 milliliter of toothpaste was ultimately diluted by a factor of 1,000. Atomic emission spectroscopy. Heat energy is absorbed by an atom, then is transferred to potential energy as the electron is excited. Then it falls back down and a photon of light is released. The light that's emitted gets detected. That's the signal or peak that is detected. Standard curve. Here's data for my standards. On the y-axis, we have emission intensity, and on the x-axis, it's the concentration of potassium. There's a linear relationship. The R-squared value is 0.995, which is close to 1. I measured the emission intensity of toothpaste samples, and then I used the calibration curve to determine the concentration of potassium in the toothpaste samples based on the equation of the line. The 3 toothpaste brands I tested were Colgate, Top Care, and Sensodyne. There were 3 trials per toothpaste. As stated previously, I used the emission intensities to measure the concentration of potassium. I accounted for the factor of 10 dilution from the toothpaste samples. Then I did unit conversions in order for my data to be in the same unit as it was on the label. The toothpaste label showed the percent of potassium nitrate as weight per volume, so that means the number of grams of potassium nitrate in 100 milliliters of toothpaste. Then I averaged the percent of potassium nitrate from each toothpaste and compared it to the label using a 1-sample t-test. When the p-value is less than 0.05%, it lets us know that the toothpaste are significantly different. Sensodyne had a p-value of 0.18, which was the only toothpaste greater than 0.05%. So it was the only one to match the label, while the others appeared to have significantly higher concentrations. Conclusion. All tubes of toothpaste analyzed in this study had at least 5% potassium nitrate. The more expensive Sensodyne was the only brand that matches label concentration. For future studies, I would suggest to test more tubes of toothpaste to be able to generalize results, use higher quality deionized water to minimize potassium contamination, and confirm potassium nitrate by measuring nitrate with ion chromatography. I would like to thank Dr. Badger from Robert Morris University, Natalie Smith from Covestro, and Dr. Knight Brown for supporting me throughout my project. These are my references. I'm happy to answer questions in the Q&A session.